Okay, so let us go. Displacement time graph. Okay, now see, till now, what is the formula? Like, what are the formula of displacement and time? Means first thing, remember that when I'm drawing displacement time graph, you should aware of formulas of displacement and time. Okay, so we know that velocity is equal to displacement by time. Next thing, displacement will be equal to velocity into time. So since I'm drawing displacement time graph, what I'm drawing displacement time graph. Remember that what will be the resultant answer I will be getting? I'll be getting the answer for the velocity. Are you able to understand me or not? See, every time, whenever you draw any kind of displacement type graph, what will happen? The resultant answer, whatever answer you might be getting, that will be related to velocity. Now, one thing is there, what I have told. Let's suppose if the quantities, let's suppose if I write one equation that A is equal to B by C. Now, if you draw the graph of B and C, what you have drawn? If you have drawn the graph of B and C, let's suppose if the line is like this way. Okay. Now, if I get the graph like this way from point P1 to point P2, remember that if I find the slope of this particular line, what I calculated, guys? I calculated the slope. How to calculate the slope? To find the, you construct one right angle triangle over here. First, you construct one right angle triangle with respect to this P1 and P2. Then you calculate this theta. This theta is what? Tan theta. If you calculate the tan theta, if you are able to calculate this tan theta, then this you will be able to understand the slope of CB graph. Which kind of graph, guys? CB graph. So remember that if A is equal to B by C, means if a fraction is there, a fraction of B and C is there, if you take B as one axis, C as one axis, whatever you draw, let's suppose if you have drawn any kind of curve, if you find the slope of that particular curve, that slope will be the answer of value A. Means this slope of CB graph is going to give you the answer of A. Got it or not? Are you able to understand me or not? Tell me. Are you
Yes,
able to
sir.
perfectly understand it? Yes or no? Everyone? Parinita, Arpita, Yasmin? Hmm?
Yes, sir.
Okay.
Yes,
So
sir.
every time, whenever, if the two things are in denominator, draw the graph, whatever curve is given, take the slope of that curve. That slope will be the answer of value A over here. Understood or not? So similarly, if I have a displacement time graph, always, this means what? Can I take that? The slope of displacement time graph is going to give you is going to give you velocity. Understood or not? Tell me. What will happen if I draw a displacement time graph? It is going to give you velocity. With all of these knowledges, I'm going to start the graph. Are you ready? Yes or no? Any kind of doubt?
Yes, sir.
Okay,
No, sir.
got it or not? Okay, so let us start these graphs. Okay, I'm going to start. Next, type A. Okay, so what is there? I have time axis along the x axis. Okay, I have this time axis. Along y axis, I'm representing by displacement. Okay, now I have drawn one line over here. What is that line? It starts from origin O and it goes. It is only flat on the time axis. What is the meaning of this graph? Can anyone tell me? What is the meaning of this particular kind of graphs? If you have a displacement time graph, our particular arrow starts from the origin and it is flat on time axis. Okay, means it is perfectly inclined to time axis. Can anyone tell me what is the meaning of this? This means that I will try to make you understand this. What does this graph is saying? Can I say that at all times, displacement of the body, displacement of the body is equal to zero? Can I say that or not? Tell me yes or no. If I'm watching this graph, this is my displacement, this is my time. What you are observing for each and every time, what is the value of displacement? It is equal to zero. Now, at what case this is possible? So if the body is at rest, let's suppose if the body is at rest, what will happen? For that body, the displacement will be equal to 0 or not? Tell me yes or no. How much time you increase? Let's suppose if I'm increasing to T1, T2, T3, whatever time I increase, for all of the times, what is going to happen? Displacement is going to be 0. So that is why I have a flat graph along the x-axis. Got it or not? So if a body have no displacement, means 0 displacement, then what will happen? It will have a flat graph. I will take one example. Let's suppose this is my road. Okay. Okay. Radha, are you here or not?
Yes, sir, I'm there.
Okay. So there I have one plant, big plant over here. Okay. I'm good at drawing, guys. See? Okay. I am aware of the drawing. Okay. Now I have one car over here. So this is my BMW. Okay. I do not know when I will be able to purchase. YouTube guys, support me, subscribe and all, so that I can purchase my BMW. Okay. So I have one car over here. Now, let's suppose this car always, like whatever, let's suppose here one observer is here. Okay, so here Hitesh is there, my favorite student. Okay, Hitesh, are you my favorite student? No, Yasmin, Ankit, all are here. Okay, they are going to kill me. Nissan, are you able to understand it or not? Tell me yes or no.
Yes, sir.
Okay, everyone, Pranita, Radha, if there will be any kind of Sanjana.
Yes, sir.
Okay, Sneha, Spursa, are you able to listen me perfectly or not? Tell me.
Yes, sir. Yes, sir.
Okay. So now look over here. If I have one observer over here who have watch in his hand, what he has watch. Now observer is watching into his watch, and what he is observing, that car is always at this position at each and every moment. 1 hour went, the car is at here. 2 hours went, the car is at here. 3 hours went, car is at here. Means what is happening? Time is increasing, but the displacement in the body is equal to 0. So for that case, I have a graph. If I draw the graph like that way, what kind of graph I will get? I'll get a graph starting from 0, t equal to 0, body was at 0, t equal to 1 hour, body is still at 0, t equal to 2 hours, body is still at 0, t equal to 3 hours, body is still at 0. Understood or not? Tell me. Are you able to understand this or not? Tell me. This graph perfectly? Any kind of doubt? No, no? Guys?
No, sir.
No, sir.
Okay.
No,
No,
sir.
sir.
Yeah. Okay. Ankit, are you here?
Yes, sir.
Okay, good guys. Now look over here. Next thing, the what can happen? Like instead, see this car was kept stationary near the plant. Okay, so you consider that position of the car is 0. But I can place this car over here or not? Tell me. Let's suppose I picked up this car. Okay, I was a muscle man. I have 6 packs and all. Okay, like great Khali. So I picked up this car and I put it over here. Got it or not? Okay. So I have put it my car over here. Now you try to understand. If it's still this, like let's suppose here the velocity of car is still 0. What will happen? The car is not going to move. After 1 hour also, let's suppose if my observer is watching this car. So what he will observe, that after 1 hour car is still at there. After 2 hours car is still at there. After 3 hours car is still at there. After 4 hours car is still at there. But there is one important point. What you are going to observe, that this car is at some distance away from the observer. Yes or no? It is at some distance away from the observer, and at this point it is kept at rest. So what is going to happen for all the times for this car, second case car, for all times, the distance d remains constant. What is going to remain constant, guys? The distance d remains constant, and that is why we can say that the car is not moving at all. So what kind of graph I will get? So look over here. For all the times, try to understand. Let's suppose the initial distance of car was d over here. Okay. Now you try to understand. For 1 hour, the distance d remains same. For 2 hours, distance d remains same. For 3 hours, distance d remains same. For 4 hours, distance d remains same. So if I have some kind of object which is kept at distance d away from the observer, and if it has raised, what kind of graph I'm going to get? I'm going to get a graph like this way, means parallel to the time axis, but it will be lifted by some kind of distance along the y-axis. Are you able to understand or not? Tell me. Any kind of doubt?
Yes, sir.
No, no?
No, sir.
Sunita, are you able to understand? Yes or no? Sparsa, Sneha, Sanjana, are you able to understand or not?
Yes, sir.
Okay. Where is Arpita? Arpita left. Okay. Now next thing. So I move to next graph. So this is graph A. This is graph B. These are two cases of rest. Okay. Now I'll move to motion. So first I have discussed type A, which belongs to which kind of cases? Rest position of the bodies. Okay. Wait. Next graph. Now I'll move to another graph. Now I'm moving to type B, which is called as motion. Okay. Now I have, like, if I consider similar example, now try to understand. This particular car is there. Okay. Means you try to understand. Okay. I'm taking one page over here. Okay. Now first case. Okay. Now try to understand that this. Okay. I'll first draw the diagram. Then after that I'll explain it. Okay. Okay, so what I'm taking, like, let's suppose initially the total distance between 2 points A and B is how much? D. What is that? I have I have 2 points A. I have another point B. Between this point A and B, how much is the distance gap? It is distance D. Now I can divide this total distance into three smaller distances: D1, D2, and D3. Now when I'm considering D1, D2, and D3, what can happen? Okay. So now look over here. When I'm considering D1, D2, and D3, what I'm doing is, let's suppose I travel this distance D1 with a similar time T1. Then I travel distance D2 with similar time T2. Then I travel distance D3 with similar time T3. So what I'm taking, if T1 is equal to T2 is equal to T3, and D1 is equal to D2 is equal to D3. So can I say that D1 by T1 is equal to D2 by T2 is equal to D3 by D3? Can I say this or not? Tell me yes or no. If this is satisfied, so these equations will be satisfied or not? Tell me everyone. Are yes or no?
Yes,
Yes, sir.
sir. Yes, sir.
Yes or no? Huh? Perfectly yes. 100% yes. Yes or no? So that means what? What is distance by time? It is speed. So what we observe, that if I travel equal distance in equal interval of time, I have what thing as constant? I have my velocity as constant. This v1 and this v2 and this v3. This d1 by t1 is what? V1 is equal to d2 by t2 is what? V2. D3 by t3 is what? V3. So what I get, if I travel in such a way that all my times are equal, and also in that time distances are also equal, then I move with uniform velocity. What kind of velocity I move? I move with uniform velocity, or I can call this as constant velocity. What I can call this as? Constant velocity. Now try to understand. So this was my formation. Okay, this I understood it, like what is called as uniform velocity, what is called as constant velocity. Now if I want to draw in the graph, what kind of graph I will get? So look over here. This is my time axis. This is my distance axis. So what you observe, that in time, smaller time t1, let's suppose you have traveled a distance t1 over here. Okay. Now if you take this gap from here to here, let's suppose if I take this blue gap from here to here, quiet or not? Okay, I'm going to make it dark. So from here to here, this gap of time axis, you understood, alright, here distances is also same, means this distance and this distance both are same. Here also this distance is same, this distance is same, this distance is same, this distance is same, and also the time gaps are similar. So when you have all the distances, like you have equal distances in equal interval of time, when you plot that graph, it will be a straight line passing through the origin. Got it or not? Yes or no? What kind of graph I'm going to get? I'm going to get a straight line passing through the origin. Remember that this straight line is going to say that we have uniform velocity. What we have? We have uniform velocity. Are you able to understand it or not? Tell me yes or no. Are you able to understand this, everyone?
Yes, sir.
Yes, sir.
Radha, Sparsa,
Yes, sir.
everyone?
Yes, sir.
Hitesh, Hitesh, कहाँ हो? Yasmin, are you able to understand
Yes,
also?
sir.
Okay.
Yes, sir.
Where is Hitesh, man? He's not telling anything. Hey, Hitesh.
Sir, here only, sir.
Hey, you are eating something na? I'll
Sir,
kill
no,
you.
sir.
Okay. If you eat alone na, I'll kill you. Next thing. Okay. Now, what we observe from here in this case of uniform velocity, that try to understand in this case what is happened when I consider this initial point at t is equal to 0, means if I consider this initial point, what is the displacement of the body? Displacement of the body was initially equal to 0, but I can start my like movement from some kind of displacement d. Yes sir, like previous case, see, the car can accelerate, car can start moving with velocity v from here, also car can start moving with velocity v from here also. So when I consider this case, what kind of graph I will have? I will have a graph passing through the origin. But when I consider for this case, what kind of graph I will have? I'll have initial distance d. From here I have uniform velocity. So this kind of graph I'll get. Let's suppose this is displacement, this is time. So what kind of graph I will get for this car? It will have initial distance, initial displacement, and after that it is moving with some kind of uniform velocity. Yes or no? Are you able to understand or not? Tell me. So look over here. If the car has initial displacement d, okay. Let's suppose if the initial car has initial displacement d, and after that it is moving with uniform velocity. So I'll have a graph which will be inclined at distance d from as with respect to the time axis. Got it or not? This line, this inclination is showing that it is moving with uniform velocity. Understood or not? Tell me yes or no. So I can take an example. Let's suppose a bus starts 2 meters away from the Times building. Let's suppose wherever you have one building name is there. So bus starts 2 meters away from the building, moving at a speed of 60 kilometers per hour. You try to understand. It has written moving at a speed of 60 kilometers per hour. Means the speed is not changing. So therefore, I will have a graph which will be like starting from some kind of distance t, and then it will be moving like it will have some kind of a straight line. Right or not? Everyone.
Yes, sir.
Yes, sir.
Okay, 1 minute. Just mm, now moving to next part. Okay, so if you want to, what I will do, I'll send this PDF to you guys. You can take the notes and all, right or not? Okay, so now move to next part. So this was the case of, these two cases are of uniform velocity. Okay, now one of the most important thing is here the initially displacement was 0. Here some displacement was initially present over there. Okay, now next case. Now, okay, you try to understand, like let's suppose now this is the same road, but I have two cars moving away from here. Now I didn't have only one single car, but how many cars I have? I have two cars which are moving in the same direction. Got it or not? Okay,
Yes.
now both of the cars, let's suppose this is my car P, this is my car Q, both are moving with uniform velocity. Okay, now let's suppose after traveling some kind of time t, let's suppose after traveling some kind of time t, I want to know that which one is moving faster. So what should I apply? That is the question or not? Tell me, so how to calculate it, sir? So you know that, let's suppose what will happen, let's suppose if this car is there, if car P is there, if car Q is there. So if one is moving faster, if one is moving slow, what should be the condition? Whatever might be the possible condition, they are going to travel this distance similar or not. Car P will also travel a similar distance t. Car Q is also going to travel similar distance t. But their velocities might be different. Their time of traveling will be different. Yes or no? So to understand about that, let's suppose if I have a car P, if I have a car Q, got it or not? Both are moving with uniform velocity, and they are covering some kind of displacement. We want to know that which car is moving faster. So what we will have to do? So first, either you can do one thing, like let's suppose here they have done little bit in a wrong way. Okay. So what I will do, I'll do just one thing. I will take this OQ, I'll construct one right angle triangle over here. Okay. Now, if when I constructed one right angle triangle, I'll get angle theta 1, yes or no? Second case for P, again I will construct one right angle triangle over here. I'll get for P some kind of angle theta 2. Now, what we observe that theta 1 is greater than theta 2. That is what we observed. Now, we know that if theta 1 is greater than theta 2, then tan theta 1 will be also greater than tan theta 2. But we know that, try to understand what I told, like let's suppose if you have, this is time, this is displacement, if you have any kind of linear graph over here. So if you measure this theta, so this tan theta is going to give you what? Let's suppose this is particle A which is moving. This tan theta is going to give you what? Velocity of particle A. Simple or not? Tell me yes or no. So look over here. In this case also, what will this theta 1, tan theta 1 will represent? What is going to happen? This tan theta 1 is going to represent velocity of particle Q, while tan theta 2 is going to represent velocity of particle P. So what I observed that velocity of Q is more than velocity of P. Remember that whenever this angle of theta with the time axis, remember which axis? Time axis. If this theta 1 is greater, then the particle will have extra velocity as compared to the particle which is moving with theta 2. Are you able to understand or not? Tell me, guys.
Yes, sir.
Perfectly, everyone.
Yes, sir.
Yasmin, Sujit, Radha.
Sir.
Yes,
Radha, are
sir.
you able to understand? Sanjana,
Yes, sir.
Sanjana, Sneha,
Yes, sir.
Sneha, are you able to understand?
Yes, sir.
Sparsa, Sparsa. After that, Parinita, are you able to understand or not? Tell me this concept of theta.
Yes, sir.
Nizant, okay, okay.
Yes, sir.
That's what I want. Yuras has joined now.
Yes, sir.
Okay, okay. Now look over here. So what we observe that if your theta 1, if this slope is higher, means remember that if slope is higher, velocity will be higher. Got it or not? So similarly, this was the case when the initial displacement was 0. But what I'm doing is, I'm considering these cars to be now having some kind of initial displacement. Okay, so car R, this is my car R, it has some kind of d1 displacement over here, while car T has this is smaller distance, initial displacement d2 over here. Okay, now the graph of both of them are there. This is again displacement, this is again time. So remember that this line is representing velocity of car T. This line R, this particular line is representing velocity of car R. Now, if someone asks you which car is moving faster, how to tell that? Again, first you have to construct one right angle triangle. Okay, so how to construct, sir? Simple, easy, tumba easy, yes or no? First, I'll draw a line parallel to the time axis for both of the cars. Okay, so when I have drawn, after that I'll construct one right angle triangle over here. I'll drop one perpendicular from both of these points. Now what you observe that for car R, theta 1, okay, and for car 2, that is T, I have theta 2. What you observe that theta 1 is very much less than compared to theta 2. Theta 1 is less than theta 2. This means what? That tan of theta 1 will be less than tan of theta 2. But what is the meaning of this? That tan theta 1 is representing velocity of car T, yes or no? And velocity of car R. While tan theta 2, this particular bigger triangle, this angle theta 2 is representing velocity of car T over here. So this means what? Velocity of car R is less as compared to the velocity of car T. Understood or not? Tell me yes or no? Yes or no? So every time when you have displacement time graph, when it is asked, when you are drawn, like let's suppose if you have a straight line, do not get panicked. Just draw this theta 1, theta 2. After that, write tan theta 1, tan theta 2. You will be definitely able to see which thing is moving faster. Understood or not? Easy or not? Tell
Yes,
me.
sir.
This trick is easy or not? Tell me.
Yes, sir.
Everyone.
Yes, sir.
Okay. Now, this was the most easiest thing. Now, we discussed about uniform velocity, but the things can happen like what? Now, what can happen? Let's suppose similar case. I'll go to this case. Now, here, first we considered that, okay, sir, let's suppose this was my total distance between point A and B. I divide this total distance in D1, D2, and D3. And I'm traveling this D1 in time T1, D2 in time T2, D3 in time T3. When I said that T1 is equal to T2 is equal to T3 and D1 is equal to T2 is equal to D3, then I have the velocity is also equal. Then I told that this is uniform velocity. But I'm considering case 2. Now case 2 is what? If still time T1 is equal to time T2 is equal to time T3. But if let's suppose if D3 is greater than D2 is greater than D1, means what has happened that for equal interval of time I have traveled distance D3 extra as compared to distance D2 as compared to distance D1, means these distances are not equal. So what you will observe that what you are going to observe guys, that D1 by T1 will be less as compared to D2 by T2 will be less as compared to D3 by T3, which implies what? That V1 will be less than V2 will be less than V3. So can you say that whether these velocities are constant? No, sir. There is an increasing and decreasing relationship over here. V1 is not equal to V2. V2 is not equal to V3. So these kind of velocities, if we can remember that, what is the property of first thing? That first thing, it should not be equal. V1 will not be equal to V2 and V2 will not be equal to V3. Second thing, we can write the which kind of relations guys? We can write this particular increasing and decreasing relation. Third important type, that their time of traveling should be equal. Then only I will say that the object is moving with non-uniform velocity. What kind of velocity? Non-uniform velocity. Remember that. How many points should be satisfied for non-uniform velocity? Three properties should be satisfied. First, what? That V1 will be not equal to V2 and V2 will not be equal to V3. Second thing, we can write this increasing and decreasing relation this greatest sign and lowest sign. Third thing, the time of traveling should be equal. Then only I'm going to call these objects as which kind of velocities, which kind of objects guys? Non-uniform velocity following objects. Are you able to understand or not? Tell me, what is non-uniform velocity? What is uniform velocity? Yes or no?
Yes, sir.
Everyone?
Yes, sir.
Yes, sir.
Ankit,
Yes, sir.
Nitara,
Yes, sir.
Sneha,
Yes.
Sarasa. Okay. Many people will do what? They will say that T1 is also not equal to T2 and T2 is also not equal to T3, but that is not the case. In both the cases, in uniform velocity and in non-uniform velocity, this time condition should be always satisfied. Got it or not? Okay. Now, when this time condition is satisfied, you try to understand. Let's suppose I have equal interval of times. Okay. I have equal interval of time. But for this equal interval of time, if I'm traveling with unequal displacement, try to understand. See this, these displacements are increasing. So what we observe, if displacements are increasing, velocity is also increasing. Okay, velocity is increasing. But one more thing is there, that this velocity is non-uniform. So when you have non-uniform velocity, so between the displacement time graph, let's suppose this is time, this is my displacement. For non-uniform velocity, what kind of graph you will get? You will get some kind of curve instead of straight lines. Understood or not? So if I have the curve, I can say that what is happening at this region, velocity, like in this region velocity is v1, this region velocity is v2, similarly here v3, v4, v5, v6. So here v6 is greater than v5, greater than v4, so on, greater than v1. Understood or not? Why? Because you try to understand that in this region displacement travel is much more as compared to this region over here. Understood or not? So if you have an increasing velocity graph, the curve will start from t is equal to 0 and also d is equal to 0, and it will go on increasing, it will go on increasing upwards. Understood or not? Tell me yes or no. So for that example, what kind of example I can give? A train departing from the station is the best example. First it has zero velocity, then it starts to move slowly, and after that it starts to cover the distances very much fast. So this is an example of non-uniform velocity. Understood or not? Tell me yes or no. Everyone?
Yes,
Yes,
sir.
sir.
Okay, no doubt. Hey, this is not fast now. I'm not doing the things fast now. Okay,
No,
No,
sir.
sir.
good. So this is little bit trickier. Okay. Now if we got to know, okay, I got to know about non-uniform velocity. But one thing is there, if someone asks you, if someone really asks you that what is the velocity at this point, let's suppose I select this point P1, what is the velocity at point P1? If someone asks you how to calculate that, we follow one special trick. So if you want to know what is my velocity at point P1, first I'll draw a tangent at this point P1 for any kind of curve I have told. For any curve, draw the tangent first. Okay. So let's suppose if I want to know about this point also, I'll draw one tangent over here. Okay. When I have drawn this tangent, I'll extend this tangent. See, here they have constructed this right angle triangle. This is also good. It is not a big issue. But I can extend this triangle over here and I'll make it till the base so that it becomes easier to calculate. Got it or not? Now for this tangent, you can calculate this angle theta1. Yes or no? Tell me this tan theta1 will be what? Uh, let's suppose this is point T2 and this is point T0. Here this is point okay, so this is point 0 over here. Got it or not? And this length from here to here, let's suppose this is length, some kind of uh, a. Okay. So here again I can calculate tan of theta1. If I calculate this tan of theta1, this will be what? A by T2 minus T0. And this tan theta1 is going to give you what? Velocity at point P. Understood or not? So whenever I want to know that what is my velocity at point P in a curvical kind of path, first I'll draw the tangent. I'll calculate the slope of that tangent by constructing one right angle triangle over there. If I can construct this right angle triangle, then I know this length of this particular hypotenuse and all, and I know this angle theta1. If I can calculate tan theta1, which is my slope, this is definitely going to give you velocity over here. Are you able to understand or not? Asparsa, Sneha, Sanjana, are you able to understand or not? Tell me yes or no. Guys, Sparsa,
Yes,
Sneha,
sir.
Yes, sir.
Parinita, are you able to
Yes,
understand?
sir. Yes, sir.
Ankit, Nishant, Arpita, are you able to understand or not? Tell me. Any kind of doubt till now?
Yes,
Yes,
sir.
sir.
Okay. So one most important thing, what you should remember that for any kind of curvical path, you have to draw the tangent, draw a right angle triangle over here. Okay. One most important point, let's suppose if I consider next concept. Okay. So again, I have this displacement time graph. Okay. So Sagalaga boom boom, let's start. First concept, the smallest concept, two concepts I'll give. Okay. Then I'll give big example of it. Okay. So let's just start. Okay. So this is my displacement. This is my time. I have a curve like this way. Okay. Then I have this displacement. I have my time. I have a curve like this way. Okay. I consider this point P1. I consider this point P2. Now, you try to understand when you draw the tangents at point P1 and point P2, what you are going to observe that for point P1, tangent is going to point upwards or not. Tell me yes or no. See, this will be my tangents or not for point P1. For point P2, if I draw the tangent, this tangent direction will be downwards or not. Tell me yes or no. Yes or no.
Yes, sir.
So look over here. Remember this. If you have a displacement time graph, if I have drawn a curve over here, for that curve, if the tangent point upwards, that means what? Velocity is positive. First concept. What is the concept? Tangent upwards means velocity is equal to positive at P1. Tangent downwards, this implies what? That velocity is nothing but, let's suppose for this graph, for this displacement time graph, what is happening? This tangent is pointing downwards. That means what? Velocity is nothing but negative at P2. Are you able to understand or not? Tell me yes or no. These 2 points, case 1 and case B. Everyone? So
Yes,
let's
sir.
suppose if I have this displacement, if I have this time, if I have drawn many curves over here, okay, I have the biggest curve, different kind of curve, okay. Now, if someone asks you that, okay, again, this is pointing upwards, so normal curve. So now look over here. If I ask you that if I give point P1, point P2, point P3, and point P4. If someone asks you that draw that where the velocity is there, where the velocity is positive, so what you will have to do? You will have to draw the tangent at all these points. So let's suppose if I draw the tangent at point P1, it is like this. Okay, right. It is like this way. For point P2, what kind of tangent I will have? The tangent will be pointing downwards. For point P3 again, the tangent will be flat. Okay. For point P4, again the tangent will be pointing downwards. Okay. Now, what is the meaning of all of these things? So for point P1, velocity is positive. Got it? For point P2, velocity is negative. But what is for point P3? That means what? At this maximum point, when the tangent becomes flat with the time, remember that velocity is getting 0. What is getting? Velocity 0 over there. For point P4, again the velocity becomes negative. Are you able to understand or not? Tell me on all of these points, the combination of all these points, yes or no? Everyone?
Yes,
Guys?
sir.
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Okay. Good, guys. Now, based upon this, I'm going to derive some fundamental theorems. Okay, so I have this first theorem. So let's suppose if I have a displacement time graph, okay, and the graph is like this way. Let's suppose for this displacement time graph, if I have a curve like this way, I want to know, let's suppose this is my point P and this is my point Q. I want to know that what is the velocity of the particle, what is the relationship between the velocity of the particle at point P and Q. So what I will do, I'll draw the tangents. But I observe that for point P, the tangent is pointing upwards, while for point Q, the tangent is pointing downwards. That implies what? That velocity of one is more than velocity of Q. Velocity of point P, look over here, what I will write, that velocity of point P is greater than velocity of point Q. Why? Try to understand when I consider this point, like suppose point R, what is happening? The tangent is becoming very much flat. Okay, so that means what? This velocity from V1 to V2, what is happening? Velocity is actually from going to here to here, the velocity is actually decreasing. Velocity of point P is positive while velocity of point Q is negative. Understood or not? But you try to understand one most important thing, that the curve is still pointing, curve is still going upwards. What is the nature of curve? First try to understand. Nature of curve is what? It is still going upward. Okay, but what we observe from the velocity, that velocity of P is less than velocity of Q. So can I say that this is the case of retardation? Can I say that this is the case of retardation? You try to understand. Let's suppose a road is there, a bus is there over here. Okay, a bus is there. Okay, so it was moving with some kind of velocity. Okay, it was moving with some kind of velocity on this straight path. Okay, after seeing that, let's suppose there is one gadda over here, means there is one pit over here. What the bus does? He applies some brake over here. What will happen? The velocity, let's suppose if bus comes over here at this point Q, this is my point P. Okay, what you are going to observe, that the velocity of bus at point Q is less than velocity of bus at point P. But still the bus is covering some kind of distance over here. When it is covering some kind of distance, that means what? That the displacement is positive, but the velocity is decreasing. So remember that for if the displacement is positive and the velocity is decreasing, the curve will be, nature of curve will be upward, while the tangents will be becoming smaller. Tangents will be first positive, then it will start going to negative. Are you able to understand or not this point, this kind of point? Yes or no? This particular point of tangent of like if the body is moving in forward direction, still the velocity is decreasing. What kind of graph will be there? Are you able to understand or not? Tell me. Any doubt, guys?
No, sir.
No, sir.
Sanjana, Arpita,
No, sir.
confirm
Yes,
now. Parinita, this kind of thing, this is very much
yes,
interesting
sir.
point. Okay, Yuvraj, are you able to understand or not this kind of point?
Yes, sir.
Okay, so look over here. See what I've been saying. The the graph is a curve. This indicates that the velocity of body is not uniform. First important thing. Second thing, the tangents at point P1 and PQ. The curve gives the velocity of body V1 and V2 at the instant T1 and T2 respectively. It is clear that the slope of tangent at P is greater than the slope of tangent at Q. The slope over here, try to understand, this is theta1, this is positive, while this theta2 is tan of theta2. This is tan of theta2. It is negative for theta2, which is obtuse. Tan becomes negative. So that means what? Velocity of 2 is less than velocity of 1. This implies that the velocity of the body is decreasing with time. That is, the body moves with the retardation in the positive direction as the displacement of body increases with time. Remember that this retardation word is very much confusing. Got it or not? Okay. Tomorrow, particularly tomorrow, when I'm going to deal with this retardation and acceleration, I'm going to talk what is the meaning of retardation. Whatever you have studied, I'm damn sure it will be wrong. Got it or not? In every book, it is not written perfectly. Okay. So I'm going to do this concept of retardation. Okay. What is called as acceleration and what is called as retardation. You need to understand the meaning of this. Got it or not? Okay. Now, you just try to understand what is retardation. Over retardation means the velocity is decreasing. That's all you need to know. Okay. Now, similar case, if I consider, you try to understand that what is happening with body now. Let's suppose if I have a road. Okay. If I okay first before, because all of these are now retardation cases. Okay. Three cases are still there, 1, 2, and 3 of displacement time graph, but I need to discuss this concept of acceleration and retardation. Okay, can anyone tell me what is retardation? What is the meaning of retardation? Yuras, I'll start with you only. What is retardation? Accept the definition that it is decrease in velocity. Yuras,
सर जब वेलोसिटी डिक्रीज सर टाइम के रिस्पेक्ट में होती है सर
that's what I'm saying. You didn't have to tell that definition.
क्या सर
You didn't have to tell that definition. Hello, YouTube family. Anyone else? Sanjana, what is the meaning of retardation? Yes, except Yasmin and Hitesh. Okay. Okay, Yasmin, also tell me what is the meaning of retardation, because I didn't have dealt this particular concept in the class.
Negative acceleration.
Negative acceleration, everyone knows that. If you have told negative acceleration, what is the meaning of negative acceleration? Arpita, Parinita, Sneha, Sparsa, you have heard about this retardation word in class 9th or not? Yes or no? Or sir, we have heard. But what is the meaning of retardation? Can anyone tell me? Hello, Sudarshan. Hi, Kedarji. Hi, Venkatesh sir. Can anyone tell me what is the meaning of this particular thing? Okay. Okay, I'll start this concept. This is the very much important concept. You try to understand this. Okay. Now, let's suppose if I have a road. Again, one example of car driven by Hitesh. Okay, this time I'm not going to take my example. Okay, this is the car of Hitesh. Okay, now let's suppose it was moving with some kind of velocity v. Okay, when it was moving with velocity v, it was like let's suppose it was having some kind of acceleration at that time. Okay, now what is happening? Let's suppose here one breaker is there. Means one. Have you seen the roadblocks or not? Tell me so. No, you have seen the roadblocks. So here you have some kind of roadblocks. Okay, yeah, particularly you have some kind of roadblocks. Okay. Now, let's suppose after watching this, Hitesh applied some kind of brake. So if it is moving, let's suppose if the car is moving in the forward direction with some kind of acceleration, with some kind of velocity, what will be the rotation of these wheels? This rotation will be along the clockwise direction. Yes or no? Where will be the rotation of the wheels? It will be along the clockwise direction. But as he sees this particular breaker over here, he will apply one brake And when he is going to apply the brake, what is going to happen with the car? Let's suppose if the car reaches at this position, okay, let's suppose this car reaches over here. So what will happen with the particular car? What is the tendency of these wheels? Can you tell me? The tendency of the wheels is to rotate in the opposite anti-clockwise direction or not? Tell me yes or no. When he applies the brake, the tendency of wheels is to rotate in opposite direction. Okay, in opposite direction. Now you try to understand this thing. What I'm trying to make you understand. Okay. So now let's suppose here, if I have some kind of, let's suppose this was my initial velocity v1, here I have final velocity v2 after traveling time t. You know that, let's suppose if this velocity v2 increases with respect to v1 in time t, I call this as acceleration v2 minus v1 divided by time. Yes or no? I call this as my acceleration. But what if velocity v2 decreases with respect to v1? If I calculate this acceleration, what I get? I get negative, I will write negative v2 minus v1, or wait. What this value will be? Let's suppose if I calculate, it will be again v2 minus v1 divided by time. But this value will be negative value or not? Tell me yes or no. This value will be positive value. What I understood, that in both the cases, what we got, that in one case acceleration is positive, in another case acceleration is negative. But still these two things are happening in which direction? In the direction of forward motion only. In the direction of forward motion only. Now in one case, when the acceleration is positive, I'm going to call this as a normal acceleration. In one case, when the acceleration becomes negative, I'm going to call this as retardation. I'm going to call this as retardation. But you try to understand one biggest important point, that acceleration and retardation happens in both, like though both of these quantities, this acceleration and this retardation, both of them happens in only one direction, and that is forward motion of the direction. If someone says you that whether the retardation is happening in the opposite direction, the answer is no. Retardation is not happening in opposite direction. Retardation is happening along the direction of forward motion. But the magnitude of retardation is equal to negative of acceleration. Are you able to understand me or not? Tell me yes or no. Any kind of doubt till now? Guys, tell me.
No,
No.
sir.
Yes, sir.
No, no. Remember this. Remember this biggest point. This is the biggest confusion between the students all over the India. Okay, that retardation is actually the opposite of acceleration. It will work in the opposite direction of the acceleration. No, that is incorrect. Both of them works in the forward direction only. But what is happening? In one case, velocity is increasing. In another case, velocity is decreasing. When velocity is decreasing, we call this as retardation. When velocity is increasing, we call this as acceleration. But what should be the direction of both of these, acceleration and retardation? Along the forward direction of motion. Are you able to understand or not? Tell me yes or no. Yes or no?
Yes, sir.
Yes, sir.
Yes or no?
Yes, sir.
Able to understand about this directional concept of retardation and acceleration. Magnitude wise, I know you guys are okay, but the direction is very much important to understand. Okay, everyone, okay or not? Radha, Sanjana, Sneha, Sparsha, Sujit, Yasmin, Yuvraj.
Yes.
Yes, sir.
Now
Yes,
are
sir.
able to understand or not?
Yes, sir.
Good now. This is a good thing now. Okay, now based upon this, we'll talk about this graph. Okay. Now you try to understand. See what is happening. So let's suppose I was moving. Let's suppose I have one particular car. Okay. So this is my bus over here. Okay, this is my plant. So what bus has to do? Bus has to first go towards the plant. After that, what it will do? It will return back from the plant. Okay, it will return after covering this distance. After covering this distance d, it will again return back. It will turn back from the plant. Now, if someone asks you, draw the graph of it. How come you will draw the graph? First, you try to understand. It was having some kind of final velocity v, v1 over here. But this velocity is going to decrease over here. Means what will happen at this point Q? What is going to happen? Velocity v2 will be there, and relation will be what? v2 will be less than v1. But when it turns back, what will happen? v2 will be greater than when it turns back, this v1 again becomes greater than v2. Means in both the cases, similar relation of velocity we are getting. But what is happening? Direction of these velocities are different, yes or no? Here, the direction of like decrease in the velocity is along this side. Means what is happening along the forward direction? Retardation is happening. But in the backward direction, when it is moving towards backward, acceleration is happening. Where the acceleration is happening? In the opposite direction. So you try to understand. First case, what is happening, guys? Retardation is happening. Retardation. And in second case, what is happening? Acceleration is happening. So can I say that the retardation is happening along the direction of motion while acceleration is happening opposite to the direction of motion? Can I say that or not? Tell me yes or no. Can I say this line or not? Everyone, tell me
Yes, sir.
that
Yes, sir.
the
Yes, sir.
retardation. We see along where is the direction of motion of the body? This is my direction of the motion of the body. Remember that in this direction, what is happening? Retardation is happening. Means along the direction of the motion of the body, retardation is happening. But opposite to the direction of motion of the body, what is happening? Acceleration is happening. So if someone tells you draw the graph of it, how come you will draw the graph? If this change in velocities are uniform, means this retardation is uniform and this acceleration is uniform. How to draw that? So let's suppose if you are decreasing your equal, like let's suppose if the velocity decreases uniformly, means let's suppose whatever might be the velocity, first it covers like distance d1 in time t1, then it covers a smaller distance d1 in time t1, then it covers much more lesser distance in time t2. So what you will observe that this all the ratio of d1 by t1, d2 by t2 all are going to be same. So if you have uniform retardation, if the velocity decreases uniformly, here at this point P, you will have maximum velocity v1. Then your velocity will start to decrease and it will become 0 over here. Where it will become 0? At point Q, it will become 0. But after that, you try to understand, this graph is not over yet. Okay, here it is over, but it is not over yet. So where I will draw next? I can draw this line in this direction or not? Tell me yes or no. So this means that from this point, again, from Q point, the particle starts to accelerate and it is moving in opposite direction. So this is my direction along the movement. This is direction opposite to the direction of movement. Got it or not? Yes or no? So try to understand. In first case, in first quadrant, this slope is decreasing. This slope is negative. Velocity is negative. While in this fourth quadrant, what is happening? This slope is increasing. If you see that what is the angle made with the x-axis, it is acute angle. While here the angle is what? Obtuse angle. Are you able to understand or not? Tell me yes or no. Everyone, guys, are you able to
Yes, sir.
understand perfectly? So if the
Yes, sir.
motion of the body, if the velocity decreases uniformly and also the body changes its direction, then I will draw and then I'll have to draw the graph like this way. First, the velocity will decrease uniformly. Then but since the particle has changed its direction of motion and it is accelerating in opposite direction, so the graph will go down and down and down and down. Are you able to understand or not? Tell everyone. Everyone, Nissan, especially you, are able to understand this or not?
Yes, sir.
Yes, sir.
Perfect now. Parinita? Parinita, are you able to understand?
Yes, sir.
Radha, understood or not?
Understood, sir.
Sanjana, perfect.
Yes, sir.
Sneha, perfect or not? Sneha, Sneha is sleeping. Sparsa, are you able to understand or not? Sparsa, hello. It is
Sir.
okay. Everything? Any kind of doubt?
No, sir.
Okay. Yasmin and Yuras, this was okay or not? Tell me how to change the direction. What will be
Yes,
the
sir.
retardation, meaning of retardation? Yasmin, okay or
Yes,
not?
sir.
Again, tomorrow I'll give you the proper definition of acceleration and retardation, and I'll complete this motion in 1D. Remember that motion in 2D, I'll discuss this relative speed directly in motion in 2D. Got it or not? Because mind relative velocity will be very, very much difficult as compared to the relative velocity what you are studying right now. Okay. So I'm going to talk about this relative velocity in that class. But see, before that, I'll complete many things. Okay. So acceleration and retardation tomorrow, and also velocity time graph, and these two graphs are still left. Okay. Two types of graphs are still left, which I need to discuss. So tomorrow velocity time graph, acceleration and retardation, and these two graphs I'll complete in tomorrow. Yes or no? Okay. Any kind of doubt? No, na?